This is a presentation about an ATM system with fingerprint scanner by Miles Choquette and Bruce Fong. Today I will be presenting the comprehensive work we've done this semester on the development of an ATM system with a fingerprint scanner. This presentation will cover 4 key documents: the software design document, the system requirement specification, the system design document, and the system test document. Let's begin with an overview. The primary goal of our project is to enhance the security and user convenience of ATM transactions through the implementation of fingerprint authentication. The system allows users to perform standard ATM operations such as cash withdrawal, balance inquiry, fund transfer, and account statement generation. The scope of our work included both software and hardware integration, focusing on user authentication using fingerprint technology. The software design document outlines the architectural design, data design, component design, and human interface design of the ATM system. Key components include the customer display, card reader, keypad, fingerprint reader, cash dispenser, and network interface. The architectural design ensures that each component interacts seamlessly to provide a secure and efficient user experience. The system requirements specification document provides a comprehensive and detailed description of the functional and non-functional requirements for the ATM system with fingerprint authentication. This document is crucial for guiding the development process, ensuring that all aspects of the system are well defined and aligned with the stakeholder expectations. Key sections of the SRS include user interface requirements. These requirements specify how users will interact with the ATM system. It includes details about the layout and functionality of the screens, such as the idle screen, login screen, main menu, and transaction screens. The goal is to provide an intuitive and user-friendly interface. Hardware and software interfaces. This section describes the interaction between different hardware components, like the card reader, fingerprint scanner, cash dispenser, and the ATM controller. It also covers software interfaces detailing how the ATM software communicates with the bank's backend system and other external systems. Communication protocols. The SRS outlines the protocols used for secure communication between the ATM and the bank servers. This includes protocols for data encryption and secure data transmission, ensuring that all sensitive information is protected. Functional requirements. These requirements detail the specific functionalities the ATM must provide. Key functionalities include authentication. Users must authenticate using their fingerprint and PIN. Cash withdrawal. Users can withdraw cash from their accounts after successful authentication. Fund transfer. Users can transfer funds between accounts. Account statement generation. Users can request and print their account statements. The SRS ensures that all stakeholders have a clear understanding of what the system will do and how it will perform, setting a solid foundation for the development process. The non-functional requirements outlined in the SRS are crucial for ensuring the ATM system's overall robustness, security, and performance. These requirements define the system's quality attributes, making sure it operates efficiently under various conditions and meets user expectations. Key non-functional requirements include reliability. The system must have an uptime of 99.9% of the time, ensuring that it is available to users at almost all times. This involves implementing redundant systems and real-time monitoring to quickly address any issues that arise. Availability. The ATM should be accessible 24/7 with backup systems in place to ensure continuous operation, even during maintenance or unexpected outages. Scheduled maintenance is to be conducted during off-peak hours to minimize user impact. Security is paramount. The system uses AES 256 encryption for data storage and SSL TLS protocols for data transmission, protecting sensitive user data from unauthorized access. Additionally, multi-factor authentication for administrative access and regular security audits help maintain a high security standard. Maintainability. The system's architecture must be modular, allowing for easy updates and maintenance. This involves clear and consistent code documentation, as well as automated testing and deployment pipelines to facilitate smooth updates and fixes. Portability. The software should be portable across different ATM hardware platforms, utilizing standard APIs and protocols. This reduces hardware dependency and ensures that the system can be easily adapted to various hardware configurations. Performance. The system is required to process user inputs and respond within 2 seconds, ensuring a quick and efficient user experience. This includes optimizing database queries, ensuring efficient network communication, and implementing load balancing to handle peak usage times. These non-functional requirements ensure that the ATM system is not only functional, but also reliable, secure, maintainable, portable, and performant, providing a robust solution that meets both user and stakeholder needs. The system design document is an essential part of our development process, providing detailed specifications for the ATM system's external interfaces, design constraints, and additional materials to ensure comprehensive understanding and implementation. User interfaces. This section details the design and functionality of the ATM's user interface. It includes screen layouts for various transaction types such as login screens, main menu, cash withdrawal, balance inquiry, fund transfer, and account statement generation. The goal is to create an intuitive and user-friendly interface that enhances user experience. Hardware interfaces. This part specifies the interaction between the ATM's hardware components such as the card reader, fingerprint scanner, cash dispenser, and display screen. Each component specification, connection, methods, and data formats are outlined to ensure seamless integration. Software interfaces. The document details how the ATM software communicates with the bank's backend system and other external systems. It includes API specifications, data formats, and protocols used for secure and efficient data exchange. Communication protocols. To ensure secure data transmission between the ATM and the bank servers, the SDD specifies the use of SSL, TLS protocols, and other encryption methods. This section ensures that all sensitive information is protected during communication. Design constraints. This section lists any constraints that affected the system's design and implementation, such as regulatory compliance, hardware limitations, and environmental constraints. These constraints ensure that the system adheres to all necessary standards and operates reliably under specified conditions. Additional materials. The SDD includes user manuals, maintenance manuals, test cases, and compliance documents. These materials provide comprehensive guidance for users, maintenance personnel, and testers, ensuring that the system is well understood and properly maintained. Overall, the SDD ensures that all components of the ATM system work together cohesively, meet the defined requirements, and provide a reliable and secure service to users. System Test Document. The System Test Document outlines the comprehensive testing strategy to validate the ATM system's functionality, performance, and reliability. The testing approach includes unit testing, integration testing, system testing, performance testing, security testing, user acceptance testing, regression testing, exploratory testing, and beta testing. Each phase is crucial to ensure system meets all specified requirements and functions correctly. Unit testing. This phase involves validating individual components in isolation to ensure each module functions correctly on its own. For example, we test the fingerprint scanner, card reader, and cash dispenser separately to verify their individual functionalities. This phase helps in identifying and fixing defects at an early stage, ensuring the reliability of each component before integration. Integration testing. After unit testing, we proceed to integration testing, where we ensure that the components function together as expected. This phase tests the interactions between integrated components, such as how the user interface module communicates with the transaction processing module. Integration testing helps identify issues related to data flow and interface mismatches between different modules. System testing. System testing validates the end-to-end functionality of the entire ATM system. This comprehensive testing phase covers complete workflows such as cash withdrawal, deposit, balance inquiry, and fund transfer, to ensure the system behaves as expected under various conditions. By simulating real-world scenarios, system testing verifies that the system meets the specified requirements and delivers a seamless user experience. Performance testing. In this phase, we assess the system's performance under various loads and conditions. We measure response times for transactions, system throughput, and transaction handling capacity during peak loads. Performance testing helps identify potential bottlenecks and ensures that the system can handle high volumes of transactions efficiently without compromising on response times. Security testing. Security testing is crucial to ensure that the system protects sensitive data from unauthorized access. This phase involves testing data encryption mechanisms, access controls, and conducting penetration tests to identify vulnerabilities. Security audits are also performed to verify compliance with security standards and best practices, ensuring the system's robustness against potential threats. User acceptance testing. UAT involves gathering feedback from actual end users to validate that the system meets their requirements and expectations. This phase includes conducting testing sessions with users who provide insights on usability and functionality. Based on their feedback, necessary adjustments are made to enhance the user's experience and ensure the system is user-friendly and effective. Regression testing. Regression testing ensures that new changes or enhancements do not adversely affect the existing functionality of the system. We re-execute previously passed test cases to verify that recent changes have not introduced new defects. This phase helps maintain stability and reliability of the system over time. Beta testing. Beta testing gathers feedback from a limited group of end users before the full release. The system is deployed to a small, controlled group of users who use it in their daily operations. Feedback on system performance, usability, and any issues encountered is collected, and final adjustments and improvements are made before the full release. By following these detailed testing phases, we ensure that the ATM system with fingerprint authentication is thoroughly tested, secure, and ready for development, providing a reliable and efficient service to users. In conclusion, the development of the ATM system with a fingerprint scanner has been a comprehensive project that involved detailed planning, design, and testing. The documents we produced, the SDD, SRS, System Design Document, and STD, provide a clear blueprint for the system's architecture, requirements, design, and testing strategy. This project not only enhances ATM security and user convenience, but also sets a robust foundation for future developments. Thank you for your attention.